What's up guys, in this video we're going to be doing synthetic division of polynomials. I will try and keep this one a bit shorter because my last one was like 30 something minutes and I don't think people have the attention spans to watch a maths video for that long, but yeah, let's get into it. So first of all, when would we use synthetic division? Well, synthetic division is specifically designed for when you have a divisor in the form x plus minus a. So yeah, if your divisor's in this form, then you can use synthetic division. So let's say we have x cubed plus 2x plus 7 divided by x plus 1. Okay, so we can immediately see that our divisor here, x plus 1, it is in this sort of form, so we know that we can use synthetic division. So how we want to set this up is, first we want to work out the root of, or the zero of our divisor. So that's essentially just when x plus 1 is 0. X plus 1 is 0 when x is negative 1. So put the negative 1 there, and then we want to draw something like this. This just represents like that, I guess, inverted, I guess it's like a twisted L kind of thing. That just signifies that we're doing synthetic division and not long division. I guess it's I guess they just like made it like that so you don't get confused. But yeah, you want to just put that down, and then I like to draw a line below that just so like the examiner knows, or like whoever's marking my paper knows that there is where the working is. And then in here, you want to fill this place out with the coefficients of the dividend. So coefficient of x cubed is 1, coefficient of 2x. Oh, no, we need to be careful here because there is actually a 0x squared hiding there. And then there's plus the 2x. So coefficient of the x squared in this case is 0. So put the 0 in. Coefficient of 2x is 2. And coefficient of, I guess that's 7x to the power of 0. It's just 7. Okay, so now what we want to do is, well, the first thing that we want to do is just drop this down here. And the reason why we want to do that is, oh gosh, what have I done? And the reason why we want to do that is because if you think about it, we want some value y such that x plus 1 multiplied by y gives us x cubed plus 2x plus 7. So we know immediately, like, there is no other way that we can get the x cubed other than, the only way that we can get the x cubed there is if we have an x squared somewhere in here. So we know the coefficient of that x squared is going to be 1 because the coefficient of this x cubed is 1. And since we're multiplying these together, like, it just makes sense, right? 1 times 1 is 1. So yeah, shocking, I know. So next thing that we want to do is, after we've dropped down the leading coefficient of the dividend, we want to multiply that by the root of the divisor. So we just multiply 1 by negative 1, which is negative 1, and then we want to put the result here, so negative 1 there. So let's clear that up first. And then what we want to do is we want to add the, whatever's here, in this case it's 0, we're going to add that to what we've got down here, which is negative 1. 0 plus negative 1 is negative 1. Negative 1, and then we just repeat the process, right? So it's essentially just the same thing, just repeated. This is why I guess we'd use this over long division. It's just much easier. So I say that, but I'm probably going to mess it up now. Negative 1 times negative 1 is 1. 2 plus 1, 3. 3 times negative 1, negative 3. 7 plus negative 3, or 7 plus minus 3, I guess, is 4. So yeah, very, very simple stuff. I hope I got that right. So yeah, now what we want to do from here is, we know that these are going to be, or like, it depends on whether or not we have a root. If we have a remainder. If we have a remainder, then what's on our end, or what's on the end, is going to be the remainder. If not, then these are going to be our coefficients. It's looking like we do have a remainder though, and 4 is our remainder. But let's see. So our dividend here is, its degree is 3, right? So the degree of that is 3. and the degree of the divisor is x plus 1, degree of that is just 1. So we're dividing some polynomial of degree 3 by another one of degree 1. So that means that our quotient has to be of degree 2. So we know that the x squared is going to go here, and from here we just we essentially continue putting powers of x's in next to the coefficients in descending order. So we've got the 1x, or just x squared there. And since we're going in descending powers of x, we're going to have x there because, well, we're going in descending powers and 2 minus 1 is 1. And then we have the x to the power of 0 here, which doesn't really matter because it doesn't affect anything. So this is our constant term. And since we can't have an x to the negative 1, just wouldn't make any sense, would it? We know that this 4 here is going to be our remainder. Okay, so yeah, that's it. I guess now we should probably write this in the proper form, which is, gosh, this is really messy, isn't it? Sorry about that. Which is x cubed, and I should, plus 2x plus 7 divided by x plus 1 equals our quotient, which is this thing here, which is x squared minus 1x, which is minus x, I should write, plus 3. And then we've got the plus 4 over the divisor, which is x plus 1 over here. So yeah, this is what we get. I guess I should, it's probably a good habit just to check over the working, so let's just check this over really quickly. We can multiply this whole thing by x plus 1, so this will no longer have a denominator, or it will, but of 1, and this will have a denominator 1 as well. So we'd get that this thing there, or like what our dividend is equal to x squared minus x plus 3 multiplied by x plus 1 plus 4. Now let's just expand it. X times x squared is just x cubed, it's not a very good 3, plus x squared times 1 is just x squared, negative x times x is negative x squared, negative x times 1 is just negative x, or minus x, 3 times x is plus 3x, 3 times 1 is just 3, plus 4. Now we just collect like terms. X cubed, no x squared, those two cancel, minus x, plus 3x actually, so it should be plus 2x. Plus 2x, and then there's plus 7. Does that look like what we have here? Yes, it does. So, surprisingly, I got it right. Which is wonderful. So now we've done our first example, let's go over one that's a bit more interesting. So let's say we have 4x cubed plus 6x squared minus 3x plus 2 divided by x, let's make it a bit more interesting, 2x plus 1. So, as we can see, the coefficient of the x term here, coefficient of that is not 1, which is a great shame. But everything is okay, because we can divide both the top and the bottom by the coefficient of x, which in this case is 2. So, let's divide both top and bottom by 2. Thankfully, what we get here is kind of nice. The 3 is not ideal, but it's okay. So yeah, divide both top and bottom by 2 gives us, well, on the top we get 2x cubed plus 3x squared minus 3 over 2x plus, well, 2 divided by 2 is 1. So we've divided the top by 2. Now we're going to do the same to the bottom to keep the value of this the same. So dividing bottom by 2, we just get x plus a half. Now, next step is just to find the 0 or the root of I guess I should probably call it 0, shouldn't I? Of the divisor. So x plus a half is 0 when x is negative a half. So let's write negative a half there. Do the weird upside down division thing. Then we want to put the coefficients in. So coefficient of 2x cubed is 2. Coefficient of 3x squared is 3. Coefficient of negative 3 over 2x is negative 3 over 2. Coefficient of 1 is 1. So I'm just going to put the other line down because that's what I like to do. It just helps me see it better, I guess. First thing you want to do, as usual, drop that down to get 2. Multiply the leading coefficient of the dividend, multiply that by the 0 of the... Oh, when I say 0, by the way, I don't think I've explained this in any of my previous videos. So when I say 0, the 0 of a polynomial is just when that essentially is the value of x or the value of the variable, which is it's the value that variable has to take so that the polynomial is equal to 0, right? So if we have x plus 1, the 0 of this is when that is 0, which is just when x is negative 1, right? You probably already knew that, so I don't know why I said that, but just in case you didn't know, I guess it's good to know. So yeah, multiply 2 by negative a half, that gives negative 1. 3 plus minus 1 is just 2. 2 times negative a half is negative 1. And then, oh gosh, this is probably not a very good example, but oh well. That's negative 1.5 minus 1 is negative 2.5. I'll write that as a decimal because I like decimals more, to be honest. Let me just, I'm forgetting a step here. I guess let's probably extend this a bit more. And then since we still got the 1 there, we need to do the same thing again. Just multiply this by negative a half. I don't want to risk doing that in my head and getting embarrassed, so I'll probably just write it out. 1/2 times, that's 5 over 2. That's just 5 over 4, which is 1 point. I didn't write the negative signs because it doesn't matter because the result is going to be positive, so I just didn't bother writing that down. 5 over 4 here. 1 plus 5 over 4 is, 5 over 4 is 1.25 plus 1 is 2.25. Now we are dividing a polynomial of degree 3. Why does it keep doing that? Polynomial of degree 3 by a polynomial of degree 1, which means that our quotient is going to have degree 2. So let's put our powers of x in here. So it has to be of degree 2, so we get 2x squared. I should probably put more space in there again. Plus descending powers of x, so 2 minus 1 is 1. So we're going to have x to 1 there. Don't need to write the 1, but it just helps you see, I guess. Minus 2.5 x to the power of 0. This is our constant term, so we don't need to write any x with that. And then this is our remainder. Yeah, that's it. Now we can write it in the same proper form that we did last time. So yeah, let's do that, I guess. So we can write this division here equals the quotient, this thing, plus remainder divided by the divisor. Oh, it's not 2.5 actually. 2.25 divided by divisor, which is x plus 1/2. And that is our results. So I think I'm probably going to end it there. It's probably, I don't know how long it's been, but I've recorded this video about 7 times at least. So I reckon we're good. Hopefully you understood everything. I hope I didn't make a mistake with that last one. If I did, I apologize. Hopefully you understand the principle though. Yeah, that's it for part 4. Part 5, we're going to be doing probably the rational root theorem and the fundamental theorem of algebra. Just doing some more stuff with roots of polynomials. So see you then. Bye bye.